All right, where did I put that? Good grief. I can't find anything in here. I don't know. Oh, crap. I've never been really very good at arithmetic. Uh, and in fact, when I was in the 5th and 6th grade, I used to guilt my mother into doing my long division homework for me. Little did we realize at that time that I would go on to become a math major, and that when one gets into the meat of the math major, one encounters something called the division algorithm. And so I'd like to talk to you a little bit about the division algorithm and a couple of different ways to look at it. Well, let's take a look here. I'm going to show you a physical demonstration of how division works. I have a box of matches here, and it says on the front 32 matches. There are not 32 matches here. Let's dump these out, and I'm going to start the division process. I'm going to divide the number of matches here by 6. So we got 1, 2, 3, 4, 5, 6. Okay, and just making 6 piles. And the idea is I'm going to keep these piles equal. If it looks like they won't be equal, I'll stop if it looks like I'm going to run out of matches before I can keep them all equal. So just keep on dealing out the matches. Okay. And so what you see here, in each of these 6 piles, I have 4 matches, and I have 4 left over. This gives me a physical manifestation of the division algorithm, where we have the number of matches I had is 6 times 4 plus 4, because I divided the number into 6 and piles, and at the end I have 4 left over. Okay, so with the division algorithm, we're dealing with whole numbers, natural numbers, and so we'll have one number will be the number of things that we have. We'll call that n, and another number p, that will be the number of piles that we put them in. And so n will be equal to the number of piles times the number of things in those piles plus r, and r is the number of things left over. And what we know for sure is that the number of things left over is a non-negative number, and it isn't as big as the number of piles, because if it were, we would just go ahead and fill up all of those piles and it would come out even. So here again is the formula we call the division algorithm. Okay. Okay, we've done the division algorithm for the integers, for the whole numbers. There's also a division algorithm for the real numbers. And so here I have, I'm representing a number by the length of this strip of paper here. This will be what we are dividing. And I'm representing another real number by the circumference of this paper cup here. And so what we do in terms of division is to see, okay, how many times will this piece of paper go around the bottom of this paper cup, okay, go entirely, and then, okay, yeah, it's it's actually easier to say than to do. Okay, so we go around once, twice, and we can't make it 3 times, and we have a bit left over, and that bit left over is the remainder. So we've made it around 2 times exactly, and this bit left over is the remainder. Okay, so again, the idea is that you have, in this case, we're thinking of lengths, and we have a circumference that we're going around, and so the length is equal to the number of times that you go around a circumference plus the remainder. Okay, call it a big R here. And so our remainder is always going to be greater than 0, but it will always be less than this circumference we're dividing by. Okay, so again, this is again with the assumption we have 2 real numbers, and so we do have this division algorithm that works for the real numbers. Yeah, who is it? No, I'm not doing anything. Come on in.